All right. This example is what we're going to use to illustrate what we mean by net area versus total area. But first, let's talk about negative area, because you'll notice in this integral from -2 to 0, we got, or should have gotten, -4 instead of just 4. So we need to talk about what's going on there. Well, think about what the graph of x cubed looks like. Think about what the graph of x cubed looks like. X cubed looks something like this. And so think about what's the difference between what's happening from 0 to +2 and then what's happening from -2 out to 0. Well, what should be happening there is that if I draw the graph between the area between this and the x-axis, if I'm at 2 here, probably somewhere around here, then this is the area I'm finding, and we found that this area is 4. And then we said that this area traced out is -4. And so the idea here is that if we take an area that's below the x-axis, then we're going to count that area as being negative. So if I take the integral from -2 to +2 of x cubed dx, don't do the calculation again here, because what's going to happen is that this is the same as breaking it into the 2 we just calculated. We can take the area from -2 to 0 and then add in the area from 0 to 2. Well, the area from -2 to 0 was -4, and then the area from 0 to 2 was 4. And guess what? They cancel out, and it becomes 0. This is the net area. So if it asks for the net area, that's just going to be the integral over the interval. And we don't have to consider anything else with the graph. However, if it asks for total area, total area says, wait a minute, if I get an answer of 0, that doesn't mean there's no area there. Obviously, there's area there. I can see it drawn out on the paper. So if I want to actually know how much area is covered, then I need to take that negative area that's happening right now and count it as being a positive area. So we need to figure out where it changes from being a positive area to a negative area. Where does that happen here? Well, it happens right at 0. So 0 is my cutoff point, where it splits off from going into from negative to being positive. So the total area is the trickier one. The total area says, let's take this negative area, which is from -2 to 0, and treat it separately. And then add in the area from 0 to 2. So I chose to split off this integral from -2 to 0 specifically because I know this integral, this first piece, is a negative. So how do I take a negative answer and make it positive? Well, let's just put a negative on it, so that this comes out to be -4 plus 4 and becomes 8 for the total area. And so to kind of summarize what we're looking at here, if you want net area, if it asks for net area, just take the integral, and you don't have to think about anything else. Total area is where we need to find where the areas will be negative, in other words, below the x-axis, and subtract them so that they count as positive. So that's the idea that we're using here. If we're asked for total area, then we're going to subtract the negative pieces so that they count as positive. In other words, what we're really doing here, but we're showing it by hand, is that we are taking the integral from a to b. This is just the integral from a to b of the function. And this is basically taking the integral of the absolute value of the function. So any value that ends up below the x-axis, we're making it positive so that it's above the x-axis. You'll see us use the absolute value form of this in a later chapter when we start talking about applications. But this idea of total area is that we're going to count that negative area as being positive. So let me actually pull up an example and show it to you very quickly just so that you can see what this looks like. And this is in, if you want to find this, it's in your notes on fundamental theorem of calculus. So that's the notes that we're going to look at, and we're going to kind of go into the tail end of the notes here. The last page or two of the notes, and we didn't get to that last page or two of the notes. So we're going to look at this example to take kind of the more complicated version of it, and I'm going to go pretty quickly here because I don't want to get too bogged down by the details. I want to show you the key points of the new stuff that we're looking at here. So if we are looking at the total area here, then we need to decide where we are negative and where we are positive between 0 and 2. So we can't just take the integral from 0 to 2. We need to see, does it dip below the x-axis at any point? Well, to do that, let's find the zeros. So here's how it factors. And indeed, it does hit a 0 at 1 and at 2. And this is what the graph basically looks like between 0 and 2. So this area right now is positive. It's counting as positive, and we don't need to do anything to it. So this area between 0 and 1, we know it's between 0 and 1 because it's one of the zeros of the function, is in great shape. We don't need to do anything to it. But this area between 1 and 2, we need to change because right now it's counting as negative. So instead of it counting as negative, we want it to count it as positive, so we need to negate it and subtract the integral from 1 to 2. So what this is going to do is it's going to not touch the integral from 0 to 1. It'll still count as positive, like we want it to. But then the integral from 1 to 2 would have been negative if we hadn't just subtracted it so that it counted as positive. And so now that total area will work itself out, et cetera, 1/2. So we split off and found where the graph is below the x-axis and where it's above the x-axis. And anywhere that it's below the x-axis, we said the area is counting as negative. I don't want it to do that, so I'm gonna subtract it so that it's going to count as positive instead. So this area would have been a negative 1/4, except now it gets subtracted so that it counts as adding 1/4. Otherwise, just like the last example, it would have canceled out and we would have gotten the net area to be 0. Which doesn't mean that there's no area. It means that the area below the x-axis is the same as the area above the x-axis. And if we're looking at like the net area, it's canceling itself out. So if I had just taken the integral from 0 to 2 here, I would have gotten 0. That's the net area. The total area is 1/2. All right, any questions on that?